If you want to know how a pocket watch works, you could try to carefully take it apart with tiny tools. Or you could smash it into another watch and see exactly what pieces fly out of the wreckage. To figure out what the universe is made of, scientists built a machine designed to do exactly this to the smallest particles in nature. Seeing how nature is built at its most basic level requires enough energy to actually break its smallest pieces open. This is the CERN campus. It sits right on the border of France and Switzerland, surrounded by quiet villages and the city of Geneva. But the real work happens 100 meters underground. Down here is the Large Hadron Collider, a massive circular tunnel stretching 27 kilometers around. Building this deep allowed scientists to bypass complex property laws on the surface. It also keeps the machine perfectly flat and uses the thick earth as a natural shield to absorb any radiation produced during the experiments. Because the requirements of particle physics are so extreme, this massive engineering project has to stay hidden beneath ordinary towns to safely exist. Inside that 27-kilometer ring, scientists push protons to travel at speeds that approach the absolute limit of the universe. This table tracks a particle speed as we add energy. A proton reaches 99.9999991% the speed of light. At the bottom, energy keeps climbing even as speed maxes out. Turning these particles requires an incredible amount of force. To force the particles to stay on track, the collider uses thousands of massive magnets. These are chilled to temperatures colder than deep space to give them the power they need to bend the beam. To build them, they use 10,000 tons of iron, which is more iron than you would find in the entire Eiffel Tower. The true marvel isn't just reaching these speeds, but precisely controlling that massive momentum along a continuous curve. Eventually, these tracks force two proton beams to cross and smash together. The total energy of one of these crashes is actually very small. It is only about the same amount of energy a single mosquito uses to fly. But inside the collider, that mosquito's worth of energy is squeezed into an area millions of times smaller than a speck of dust. To capture a crash that dense, scientists built the CMS detector. It is essentially a 5-story digital camera designed to photograph the wreckage. This machine is built like an onion, with different layers wrapped around the collision point. When the crash happens, the proton skiers fly outward. Specific layers of the detector are designed to catch and identify these pieces as they pass. Making the collision happen is just the first step. You need the precision of a multi-layered camera to capture those pieces before they vanish. Because these particles are so small, getting a direct hit is difficult. To increase the odds, the collider snaps a new photograph of these interactions every 25 nanoseconds. This creates a mountain of information. Every year, the collider produces 15 petabytes of data, enough to fill about 100,000 DVDs. Modern physics is now a digital challenge, using massive computing power to sift through billions of ordinary events to find a single interesting anomaly. Ultimately, this data is used to check our best instruction manual for how the universe works. By identifying rare, never-before-seen pieces in the debris, scientists can figure out the rules that govern every interaction in nature. These tiny rules are what allow the larger world to function. They dictate how stars burn and how the atoms in your body hold together. By building the largest machine in history to study the smallest pieces we've ever found, we are finally seeing the hidden mechanics that allow our world to exist.
If you have any ideas for my next video, just write them down in the comments below, and I will explain it in the next one. Don't forget to like and subscribe. Thank you so much for watching.